Hi students, this is AJ sir. Let's study 10th standard ICSE Math, chapter 21A, Trigonometrical Identities. Chapter 21, Exercise A. First, let's revise the definitions of the trigonometrical ratios. Sine is perpendicular upon hypotenuse, also called opposite upon hypotenuse. That's O upon H. Cosine will be base upon hypotenuse, also called adjacent upon hypotenuse. That's A upon H. Tan is opposite upon adjacent. And then we have the reciprocals of these. Cot or cotan is the reciprocal of tan. Secant is the reciprocal of cos. And cosec is the reciprocal of sine. One trick to remember this is to remember this word osha chota. S is sine, that's opposite upon hypotenuse. Cos is adjacent upon hypotenuse. Tan is opposite upon adjacent. And if you know these three ratios, you can do the reciprocal to remember the remaining three ratios. Apart from this, we have to learn these three identities. Sine square A plus cos square A is equal to 1. These are the two variations of that. Then sec square A minus tan square A is equal to 1. And cosec square A minus cot square A is equal to 1. And their variations. If you learn these formulae, exercise 21A will become very easy. So pause this video and learn them right now. Okay, now ready? Let's start with 21A exercise. Some cancellations. In solved example 3.3, cancel the alternative method. Similarly, in solved example number 4, cancel the alternative method. And in solved example number 5.2, cancel the alternative method. In exercise 21A, let's start with the second sum. The sums are very easy. Let's start with the first sum. Prove that sec A minus 1 upon sec A plus 1 is equal to 1 minus cos A upon 1 plus cos A. Now we always try to convert the trigonometrical ratios in terms of sine and cos. So since we have sec A on the LHS, we'll start with the LHS. In the second sum, on the other hand, we would have started with the RHS to convert cosec into sine. So starting with the LHS, we know that sec A is nothing but 1 upon cos A. So substitute that and then do the LCM in the numerator and the LCM in the denominator. Now notice how the denominators are same, so they get cancelled. So we are left with this, which is the RHS. So you can see that proving sums are pretty easy. Now the fourth sum. Tan A minus cot A is equal to 1 minus 2 cos square A upon sin A cos A. We'll start with LHS and we'll convert the tan and cot in terms of sine and cos. So the definition of tan A is sine upon cos and cot A is cos upon sine. They are reciprocals of each other. We'll do LCM. So this will become into sine A, into sine A, into cos A, so that the denominators will become the same, sine A cos A. The dot means multiplication, by the way. And the numerators become sine square A minus cos square A. Now always try to think after every step if any identity formula can be used. And also keep looking at the RHS. If you look at the RHS, it's visible that the denominator is sine A cos A, which we got. But the numerator has only cos square A. There is no sine at all. This gives us a hint that we will have to get rid of the sine. We should convert the sine into cos. But how do we do that? There is no reciprocal relationship between sine and cos, but there is an identity formula. Sine square A is 1 minus cos square A. So we substitute that. So now this becomes 1 minus 2 cos square A, which is RHS. Next, the sixth sum. 1 minus tan the whole square plus 1 plus tan A the whole square is equal to 2 sec square A. So LHS is more complicated, so we will start with that. There is no formula for 1 minus tan A the whole square, so we have no choice but to open the brackets using the formula A plus B the whole square and A minus B the whole square. So we get this opened and even this. Now 2 tan A and 2 tan A got cancelled because of the opposite signs. 1 plus 1 is 2 and tan square A plus tan square A is 2 tan square A. Remove 2 common, so you get this. Now think, is 1 plus tan square A equal to something according to the identity formula? Don't look at the formulae. You should have learnt them by now. Well, it is equal to sec square A, so that's how you get the RHS. Now you may wonder, why should we study trigonometrical proving? Well, first of all, it gives you some magical powers in your fingers. For example, look at this. And secondly, think of these as riddles to train your brain, to exercise them. It strengthens your logical thinking and analytical abilities. It may seem very abstract to you, but trigonometry is very useful in higher sciences and engineering. So let's start with the eighth sum. You have to prove that sec A 1 minus sin A sec A plus tan A is equal to 1. Obviously we'll start with the LHS. So first things first, convert everything in terms of sine and cos. Most of the times this works. After converting them, denominators are same, cos A. So just bring them together. And this has a denominator cos A, and even this has a common denominator cos A, so that becomes cos square A. There is no plus or minus sign here. It's a multiplication. So no LCM here. The numerators are two brackets, and this reminds me of a formula A minus B, A plus B, which is nothing but A square minus B squared. And this is again an identity. It is equal to cos square A, hence it is equal to 1, which is the RHS. Now the 10th sum, prove sec square A plus cosec square A is equal to sec square A dot cosec square A. We'll start with the LHS again. We'll convert it in terms of sine and cos. Remember, sec is 1 upon cos, so sec square A will be 1 upon cos square A. Don't forget the angle A everywhere. Similarly, cosec square A is 1 upon sine square A. Do the LCM. Now this numerator is nothing but 1. So that's how you get this denominator. And the reciprocal of sine square A is cosec square A. And the reciprocal of cos square A is sec square A. So that's how we get the RHS. Next, 11th question. We'll start with LHS again. The moment you see 1 plus tan square A, which formula comes to your mind? Well, it's sec square A. So convert that. Replace this with sec square A. That's a formula. Now convert everything in terms of sine and cos. So sec square A will become 1 upon cos square A. Cot A will become cos A upon sine A. And 1 upon cosec square A, its reciprocal is sine square A. So instead of denominator, we wrote the numerator. And now reduction. Sine A cancelled, cos A cancelled, but 1 cos A remains here and 1 sine A remains here because there is a square here. So that's sine A upon cos A, which is nothing but tan A, and that's the RHS. Next, the 13th sum. Cot square A minus cos square A is equal to cos square A dot cot square A. So again we'll start with the LHS. See here, it's converted in terms of sine and cos first. Then there is an LCM into sine square A into sine square A. Here cos square is common. So remove cos square A common, and what is left is 1 minus sine square A. What is that? It is cos square A again. So the numerator becomes cos square A into cos square A. Keep looking at the RHS. What do they want? They want a cot. How do we get that? Well, we know that cos square A upon sine square A is nothing but cot square A, and the cos square A remains as it is, and that's how we get the RHS. Next, read the 15th question. So we have bracket into bracket is equal to sine square A plus tan square A. We'll start with LHS. Now don't convert it to sine cos yet. First of all, I see that this is in the format A minus B, A plus B. So use the formula which becomes A squared minus B squared. Now in the RHS, I see that there is a tan involved. So is there any way we can convert something into tan? There is also a sine involved. So now it should strike you that sec can be converted in terms of tan and cos can be converted in terms of sine. So that's what we are going to do. We will replace this with 1 plus tan square A, and instead of cos square A you can write 1 minus sine square A. The 1 and 1 will get cancelled, and ultimately you will get this as the RHS proved. Don't forget to write RHS. Here I have used a slightly different method, which is also fine. Now the 17th sum. Bracket into bracket into bracket is equal to 1. That's a lot of brackets here. And there are no squares involved, so I can't think of using any identity yet. So the only option left is convert everything in terms of sine and cos. And let's hope that some formulae appears. Do the LCM, of course. Now I see this 1 minus sine square A can be written as cos square A. Here 1 minus cos square A can be written as sine square A. And here sine square A plus cos square A is equal to 1. There is no need to write the formulae, which formula you are using, no need to mention that. And the denominators will all come together. It's multiplication, remember. So it becomes sine square A into cos squared A. And things get cancelled, and that's how we get the RHS of 1. Next, the 19th sum. It's an IMP sum. Now things start getting interesting. Prove cosec A plus cot A is equal to 1 upon cosec A minus cot A. Now one thing I can see here is that they are conjugates of each other. That is, it's the same, just the sign difference is there. So remember, whenever a sum has a conjugate, there is a special way to solve them. I'll show you two methods to solve this, a longer one and a shorter one. First of all, the longer one would be convert everything into sine and cos. Then take the LCM, and you got 1 plus cos A upon sine A. There's nothing more we can do, I guess. So let's try with the RHS also. Let's hope that we get this in the RHS. Then the sum would be proved. Let's see what happens. So even here, convert it into sine and cos. So that's 1 upon sine A minus cos A upon sine A. All this is in the denominator. Take the LCM, and the sine A goes up. You know, the denominator goes to numerator. And we get sine A upon 1 minus cos A. Now, that's not equal to what we got here. Here we got 1 plus cos A upon sine A, and here I'm getting sine A upon 1 minus cos A. They are not even reciprocals. You can see that it's a conjugate here. It's 1 plus cos A, and here it is 1 minus cos A. So now remember, whenever you see a conjugate, we multiply with the conjugate, that is the opposite sign. 1 plus cos A, so we'll write 1 minus cos A up and down, numerator and denominator both. Because when we do this, the numerator will become A plus B, A minus B, that is A square minus B square formula. And the denominator is just the product of these. don't open the brackets yet, because 1 minus cos square A is a formula. We can write that as sine square A. So now sine A and 1 sine A can be cancelled. So what is left is sine A upon 1 minus cos A, and that's the RHS. Here, it's matching the RHS now. Hence LHS is equal to RHS. The original LHS is equal to the original RHS. But how will it strike you when to use what method? Well, by practicing, of course. 21st sum. But before that, what was the other method, a shorter method? Instead of converting it into sine and cos, what if we take the conjugate of the RHS directly? So the moment you saw the sum had conjugates, we could have started with RHS, take the conjugate of that is the plus sign, because now the denominator becomes a square minus b square, and by the way, this is a formula. It is equal to 1, and you get the LHS directly, such a short sum. So I would prefer this method. So once you are thoroughly trained, then you can start using the shorter methods. In the 21st sum again, it's bracket squared plus bracket squared is equal to blah. We'll start with the LHS, of course. We'll have to open the brackets. So we'll get a square plus b square plus 2ab plus a square plus b square plus 2ab. Nothing's getting cancelled here. There's no minus sign. However, sine A into cosec A is 1. You see, sine A and cosec A are reciprocals of each other. If you wish, you can show that step, although it's not compulsory. Cosec is 1 upon sine, so cut. Similarly, cos A and sec A can be cancelled. They are reciprocals of each other. So I've shown that step here, although it's not compulsory to show this. So only 2 remains here. So 2 remains here and here. What about cosec square A plus sec square A? Is that a formula? No, there is no formula like that. But keep looking at the RHS. We need tan and cot. Is there any way to convert them into tan and cot? Yep. This is 1 plus cot square A and this is 1 plus tan square A. Obviously, you will not try to convert it into sine and cos. That's not what is needed in the RHS. And just add them up and we get the RHS. So even the 21st sum was important. Now the 23rd sum. We'll start with the LHS and we'll do LCM. So it becomes 1 minus cos A plus 1 plus cos A, and the denominator is in the form A plus B, A minus B. Here minus cos A plus cos A gets cancelled, so 2 remains, and this becomes 1 minus cos square A, which is sine square A, and that becomes a reciprocal cosec square A. That's how you get the RHS. Next, the 25th sum. Again, I see conjugates in the denominator. So when we do LCM, something will work out. Let's start with the LHS. We'll do LCM. Now don't just convert everything into sine and cos yet, because it will become too complicated. Instead, let's solve ahead and check what we get. Open the brackets in the numerator and denominator. The denominator becomes A minus B, A plus B formula. In the numerator, cosec A and minus cosec A gets cancelled. Now, what is cosec square A minus 1 in the denominator? Is that some formula? What is it equal to? Cot square A, correct. And the numerator is 2 cosec square A. Now, convert the cosec and cot in terms of sine and cos, because in the RHS of the question, we want sec. We don't want cosec and cot. So cosec will become 1 upon sine and cot will become cos upon sine, reciprocal that's sine upon cos. Sine and sine gets cancelled. Reciprocal of cos is sec, and that's how you get the RHS. Now mark the 28th sum as IMP. Here again we'll start with the LHS and we shall convert everything into sine and cos. Students, multiple methods are possible in every sum. So if you want to try out a different method, you do that. Spending time in trial and error method is worth it because you will come up with new ideas which will only make your trigonometry stronger. So after converting it, I'll have to do LCM also in the LHS. The reason why I've converted everything into sine and cos is because in the question the RHS has only sine. So I'll have to convert them into terms of sine. Now the denominators are getting cancelled here, sine square A and sine square A. The square is for numerator and denominator both. So what I'm left with is this. But I want only sine, I don't want the cos. So that's the hint that we should convert this in terms of sine. How do we do that? The identity, cos square A is nothing but 1 minus sine square A. And this is of the form A plus B, A minus B, because it's A square minus B square. So that means one bracket and one bracket gets cancelled. And then we are left with 1 minus sine A upon 1 plus sine A, which is the RHS. Next, the 29th sum. Again, we'll start with the LHS. Don't forget to write LHS. Here we'll do LCM, of course, first. So we got bracket into bracket plus cos squared A upon the denominators together is equal to, open the brackets, this is actually A plus B the whole squared. So A squared plus B squared plus 2AB plus cos square A. In denominator, don't open the brackets. I'm reckoning that something will get cancelled. Now here, sine square A plus cos square A is 1. So that's 1 plus 1, that's 2, and 2 sine A remains as it is. Now remove 2 common so that 1 plus sine A remains in bracket. Now the bracket gets cancelled. You are left with 2 upon cos A. Reciprocal that's 2 sec A, and that's the RHS. Next, the 31st sum. Cot A minus cosec A the whole squared is equal to this. We'll start with the LHS. Convert everything into sine and cos because the RHS was in terms of cos. LCM is not required because the denominators are same. Cos A minus 1 the whole squared upon sine square A. We want only cos, we don't want sine. So that's the hint that we'll have to convert the sine square A. Yeah, the square is even for the denominator. You can show that step if you want to. I'll convert that into 1 minus cos square A. But that is nothing but A minus A square minus B squared. That is A plus B, A minus B. And then this one bracket and one bracket gets cancelled. And then I'm left with 1 minus cos A upon 1 plus cos A. Now you may wonder, how can I cancel cos A minus 1 and 1 minus cos A? Well, if you wish, you can show one step where I've flipped the terms. Because it is a square outside, the order doesn't matter even in subtraction. You see, if it is 3 minus 1 the whole squared, that is 2 square, which is 4. What if it is 1 minus 3 the whole square? That is minus 2 the whole squared, which is also 4. So because of the square here, the order doesn't matter, you can flip it. And that's how we solved the sum and got the RHS. Next, 33rd question. Again, we'll start with the LHS here. Now we have two angles, A and B. So let's convert everything into sine and cos because the RHS is only in terms of sine and cos. We'll have to do LCM, of course, into cos square B, into cos square B, into sine cos square A, into cos square A. Now, in the numerator of the RHS, we had only sine. So that's a hint that convert the cos's into the sines. So instead of cos square B, I wrote 1 minus sine square B. And instead of cos square A, I wrote 1 minus sine square A. The denominator will be as it is because this matches the denominator which is there in the RHS. Now open the brackets. Fortunately, this term and this term gets cancelled because of the opposite signs. And what we are left with is indeed the RHS. Next, the 35th sum. So here again we'll start with the LHS. You could have started with RHS as well, and you would have converted this into sine and cos, and you would have reached LHS. So try that method. Pause this video and try it on your own now. You'll get the confidence if you get it right. I reckon you won't get the LHS directly, but you'll get the conjugate of that. So you know when you get conjugate, what you have to do, multiply with the conjugate, and definitely you'll reach the LHS. It would be similar like the 19th sum. But here what I'm going to do is I'm going to start with the LHS and use the conjugate straight away so that my sum is short enough. The denominator becomes a plus b, a minus b, which is a square minus b squared. And here I'll use the formula of sine square a. That way I can cut sine and sine, and that's how I get 1 minus cos a upon sine a. Now I split it. This becomes 1 upon sine a, and this becomes cos a upon sine a, which is cosec a minus cot a, which is RHS. If you've tried the other method I talked about, then just check your steps. First we convert this into sine and cos, then no need for LCM. Bring the terms together. So 1 minus cos a upon sine a, common denominator. Multiply with the conjugate, 1 plus cos a, 1 plus cos a. Of course here 1 plus cos a is same up and down. Only then it is mathematically allowed. So the numerator becomes a squared minus b squared. The denominator, don't open the brackets here. Numerator, use the formula, that's sine square a. Sine a gets cancelled, and you get sine a upon 1 plus cos a is equal to RHS. So even this was a pretty simple method. You should have done this. 38th sum. Mark it as IMP. Now we have 3 terms multiplied by 3 terms in the bracket. There are no squares visible. So we'll have to convert everything into sine and cos first of all. Then do the LCM, we'll get the common denominator here and here. Now multiplying a bracket of 3 terms with another bracket of 3 terms will be quite difficult if you try to open the brackets, but still try it out. Let's see what you get. Now I'm going to show you a manipulation to make the sum easy. You can see that sine a plus cos a, sine a plus cos a is same in both the brackets. So how about we use this as a minus b, a plus b, where b is 1 in both the brackets. The denominator is simply sine a into cos a. Now once we write this in this format, and yes, please use brackets, a lot of brackets, this becomes a squared minus b squared. That's a formula. And now you can open the brackets of this. So this will become sine square a plus cos square a plus 2 sine a cos a minus 1 upon this. I wonder if you would have done distributive multiplication, would you have got the same answer as this? Try it out. Now here, sine square a plus cos square a is 1. Should remember these identities. 1 minus 1 cancelled. So what is left is this upon this. And even here sine a cancelled, cos a cancelled. And you're left with 2, which is RHS. So that's why it is IMP. Next, the 40th sum, another interesting sum. Because there is a root involved, you should start with LHS. Definitely. And you can see conjugates here. So multiply with the conjugate. But whose? The numerators or the denominators? Well, mostly we write the conjugate of the denominator. but you can just mentally think about it and foresee what will you get in the future. For example, here when I multiply with the conjugates, the denominator becomes the format a plus b, a minus b, which is a squared minus b squared. And the numerator is simply a minus b the whole squared. Now the denominator is a formula, so write sine square a out there. So we have square sign in numerator and denominator both. So that gets rid of the square root sign. Notice that here we could not cut because there is a minus sign available here. Now that the root is gone, it's easy to solve this further. Just split it into two fractions. You get 1 upon sine A minus cos A upon sine A. And that is equal to the RHS. Next, the 42nd sum is also a very similar sum. But the difference here is we will not take the conjugate of the denominator here. Rather, we'll take the conjugate of the numerator. We take the conjugate of the numerator here because then this will become a square minus b square, which is 1 minus sine square a, and 1 minus sine square will become cos square a, and the square root of that will become cos a. And if you look at the RHS, in the numerator we do have cos a. So you should have the foresight to justify which conjugate to take. So now the denominator also has a square, so the square and square roots get cancelled, and finally you get the RHS. If we would have taken the conjugate of the denominator here, there's nothing to worry. You would have got some other answer, but then if you would have done conjugate of that, still you would have reached the RHS. Next, the 45th sum. We'll have to do LCM in the LHS and then open the brackets. A squared plus b squared plus 2ab plus a squared plus b squared minus 2ab. It should fit on one line, so write neatly. This gets cancelled, that's nice. And a square plus b square, that is sine square a plus cos square a, is 1. Similarly, this is also 1. That becomes 2. And the denominator, I need only sine in the denominator as per the RHS of the question. So let's convert the cos into the sine and we get the RHS. Now the 46th sum is IMP. We'll start with the LHS. Now again, 3 terms are involved here. This is similar to your solved example number 5.2. One way is to convert everything into sine and cos first. If you do that, then this sum will become similar to question 38. But that's a very long method. So I'm going to show you a trick. So if you remember the trick, it will become so easy to solve this. Whenever you have such a sum, you replace the 1 with the formula cos square a minus cot square a. This is something you'll have to remember. Because by doing this, this becomes a square minus b square, which is a plus b, a minus b. And now this bracket and this bracket is common. So take out the bracket common. So what is left inside the bracket is 1 minus cosec a plus cot a. Signs will change, be careful. The denominator remains as it is. In fact, this gets cancelled. If you notice, this bracket and the denominator is exactly same. 1, 1 minus cosec a minus cosec a, cot a, cot a. So we are left with this. And now we can convert it into sine and cos, do the LCM, and that's your RHS. And finally, the 47th sum, which is also IMP. Here too, we'll start with the LHS. We'll have to do the LCM first. And then you have to open the brackets, and that's a headache because it should fit in one line. So after opening the brackets, make sure that everything fits in the same line. The denominator becomes cosec square minus cot square a. Again, I've left a line here and here, so it becomes neater. Be careful with the signs. You see there is a minus sign out here outside bracket and even a minus sign out here outside bracket. So whenever you open brackets, signs change. Also, reciprocals cancel each other. So sin a cosec a would get cancelled, and even here sin a cosec a would get cancelled and only one would remain. What about cot a? Well, sin a into cot a is cos a because sin and sin gets cancelled. So that's how we reach this step. And then cosec a minus cosec a cancelled, cos a minus cos a cancelled. What is remaining? 2 cot a plus 2. Take out 2 common and that's your RHS. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.